See Lindelof videos verifying trig identities number 2. So here we have this trig identity that we're being asked to verify or to prove. The first thing I guess I would tell you is please be sure that you realize that you're only supposed to touch one side, and it's almost always a left hand proof. So what they're saying is that we're allowed to manipulate this side of the equation, but not allowed to touch the opposite side. So let's get after this, I guess. First thing I'm going to do is just set out, and I'm going to leave this, I guess, secant squared theta. This minus sign is this one, but if you can see that we have secant squared theta, and secant squared theta is the same as 1 over cosine squared theta, right? That's this piece by the trigonometric reciprocal identities. I'm going to bring this multiplication sign is this one. Cosine squared theta is the one that's right over it, over 1, is equal to tan squared theta. Remember, not allowed to touch this side. I just brought it down. I'm going to go ahead and multiply here. I'm going to say that secant squared theta minus cosine squared theta over cosine squared theta is equal to tan squared theta. Obviously, you can see that cosine squared theta over cosine squared theta is 1. So we have secant squared theta minus 1 is equal to tan squared theta. Here we actually have this thing solved, but you have to give your reasoning or your proof that this is true. So you can say here, yes, wow, can't spell, Pythagorean identity, so Pythag ID. And what Pythag ID is it? It's the Pythagorean idea. It's the actually third Pythagorean identity. It says that 1 plus tan squared theta is equal to secant squared theta. So this is the identity that they gave us. This is a given quantity. This is a given proof right here. So we can see that just by a little bit of algebraic manipulation, we can turn it into that, and therefore we have proven this through a Pythagorean ID. All right, just one more, I guess. This one is, I think, pretty straightforward. It says that sine theta times cotan theta is equal to cosine theta. And let's see how that's true. Again, only touching the left-hand side, so remember I'm just going to bring the right-hand side down. Proving this side, I'm just going to leave this as sine theta times 1 over, oh, that's not true. That's not true. Cotan theta is, sorry, cosine theta, isn't it? Over sine theta. Sorry, guys. Okay? Hopefully you can see this sine theta and this sine theta cancel one another, so we get 1 times cosine theta equals cosine theta. Obviously, cosine theta times 1 is just cosine theta is equal to cosine theta. Have to give your argument, and my argument is this is true reflexively. Reflexively, right? If A must equal A. So cosine theta obviously equals cosine theta, but they do want a rule for it. So I'm saying reflexively that's true. Hope this is helpful. This is not impossible to do, but it is a pain. It really is. It's kind of pain. You have to do a bunch of them, and then you'll start to see it. And as you see it, I don't want to say it becomes cool, but it becomes very, very doable. So I hope this is helpful. If you have any questions or comments, let me know. And if you haven't already subscribed, please do. Thanks.